Thank you all for attending this presentation. I'm just going to take 2 minutes of your time to introduce Green Building Solution Consultancy. Our expertise in can you turn the next slide? Okay, our expertise is in complete project administration for green building certification, lead through CI existing building. We also do a complete lead for home certification that include conducting the task of green rater and resident home energy rating. Design builder software that we are going to talk about today, policy design and advisory in the area of energy sustainability and efficiency, building commissioning, renewable energy consultation, and building energy performance simulation. That's all. I don't want to take more of your time. I'll leave you for the presentation. Mr. Khan, he will start giving us all the information about this presentation. Mr. Khan, will you start? Thank you.
Mr. Khan, yes, please. Mr. Khan, you are on mute. Can you unmute it, please?
Okay, sorry. Yeah,
Yes.
Can you hear me now?
Yes, please carry on.
You can hear you.
Yeah, okay, so we'll go with the presentation and it's a brief presentation showing the capabilities of Design Builder. And once the presentation is over, we'll switch over to the software to show you the basic interface of Design Builder, how to do modeling and how the inputs and outputs are integrated, so that you have a brief idea of how the things work and what is the workflow, basic workflow, and what all possibilities are there within the software. Okay, so the key features of Design Builder. So as you can see that it's an integrated tool, and anything regarding environmental analysis and simulation we can do on a single model or a single geometry. So we can do daylight simulation, we can do HVAC modeling, and within HVAC modeling we can go up to any details of controls. Then we can even perform natural ventilation simulation, solar PV simulation, hot water simulation. And apart from this, we have separate dedicated modules for compliance with ASHRAE 90.1 and LEED for different credit for energy, daylighting. Then for the researchers, or for those who want to optimize their design, or who are working in the research areas, they have parametric optimization and scripting option available as well. Then we can perform even CFD simulation within this, and we have LCA integration and simulation result analysis, which we do basically, which we can do within the software, and we have an external freeware software available as well for detailed analysis, post processing. Okay. So these are some of the, the outputs and the graphical things which are there in a Design Builder. We have discussed this thing in the previous slide as well, so we are moving ahead. So basically Design Builder is targeted. So if you are an architect or an engineer, or if you are working with a sustainability consultant, or suppose you are working as an energy assessor, or you are within a university doing research on built environment sustainability, built environment energy, thermal comfort, so all these things, or if you have something related to this, then Design Builder is the best software which is available, and you can integrate all the domains within the architecture, engineering background, and within within the research part within the same interface. These are some of the outputs of you can see the 3D model that we have developed. So you can see that we can model any kind of geometry, we can model shading, we can model even solar PV on the roof, and we can model even the green roof if the design has this, or if you want to see the impact of green roof within the zone, within the or the temperature profile and the cooling loads. So we can do that even. So any kind of complex geometry, any even, so that we can perform even. Yeah. So these are some of the outputs of the models that we have prepared. Then so if you see, then within the visualization tool we can export the outputs in the 3D outputs. So for the client presentation, so instead of showing data in a tabular form or in a data form, the design builder, what it does, it overlays the output information or the input information on the 3D geometry itself. So if you want to see what amount of solar radiation is falling onto a surface, or what is the thermal comfort of different zones, so that we can extrapolate within the 3D module, and then that information which is in output within the tabular form, it get reimposed within the 3D output form. And so it's basically very easy for the clients and for our and for the person in front to understand that what kind of output we have generated and what is the possible impact of that on the design, on the measures that we have taken on the design. For daylighting, if you see within the design builder, so we can perform point in time daylight analysis, we can perform annual daylight analysis. Then for we have integration with the lead version 4, lead version 4.1, lead version 3. So all those lead modules are inbuilt, integrated within the design builder. And even we can generate reports from the design builder as well. And apart from that, you can see that we can generate 3D outputs for our 3D model. So we can see, okay, what kind of spatial distribution of daylighting is there within the zones and in the corridors, or any kind of space that we have designed. So for the lead, we have all the options, option 1 and 2. So point in time daylight analysis and annual metrics, both we can do within the design builder. So these are all the simulation outputs which we can perform from lead version 2 to lead version 4.1, which is the latest lead version right now. Then we have BREEAM as well, we have Green Star, and then we can perform even well credits as well for within the design builder. So this is one of the output of a simple shoebox model that we did. I'll show you how to just quickly model this thing and see if your design is complying with lead or not. So it's a very quick process, and then we can see and what needs to be done to make sure that we are complying with any of the rating authorities that we are trying to comply with. Then one of the most important feature that we face right now is that because of the integration of the design and multidisciplinary teams working across nations, we basically received multiple format files. So for example, we may receive a Revit file which is developed by the design or the BIM team, and so design builder has a dedicated plugin which we can install within Revit. And then what that plugin will do, it will basically simplify that model, and it will convert the BIM model to BEM model. So from building information modeling to building in energy modeling, and it will simplify, and it will take out only that information which is required for the modeling purpose, for the environmental analysis, and then it will export that file, import that file within the design builder, and then we can post process the for working within the design builder. So for the geometry part, we don't have to spend much time in the modeling front. Similarly, if we have a PDF file, suppose we don't have a CAD file, so we can import the PDF file, we can scale it down, and then we can export the geometry. We can even import the CAD files, we can import the image files, we can import the files from Rhinoceros using GBXML format. Or so these are multiple different interfaces, which basically these are the input interfaces which design builder supports. And then within as an output, we can export the design builder outputs into multiple software. For example, MagicCAD is there, which mostly the MEP consultants can use. Then we have one-click LC analysis, which is an external tool, but which it has been integrated within the design builder so as to see what is the carbon impact, CO2 carbon footprint impact of our building. So that we can do. So possibilities are endless in a way. we can import multiple formats and we can export multiple formats and share across the design teams for possible integration and design optimization. Okay, so you can see on the left and the right. So on the left, you can see it's a Revit model, but after using the plugin for the design builder, if you can see, it's a small icon within the Revit interface. So this after using this plugin from design builder, it has converted this Revit model into a design builder model, and we don't have to do all the zoning stuff and all the modeling stuff. So it basically saves a lot of time once you are doing with the dealing with the complex models, and or so that saves a lot of time. Then HVAC modeling. So within design builder, we have two options for our HVAC modeling. One is a simplified method, wherein we can just pick and choose what system we want, and with the basic controls and coefficient of performances, we can perform the annual simulation, or if you want to compare two systems. But then there is another module, which is the detailed module, wherein we can model each component of the design. So we can model chillers, we can have all the set point managers, we can control humidity, we can control air temperature, or any kind of input which is there in the design. It can be modeled, and we have the pre-made modules for most of the possible systems which can be modeled, from radiant system to underfloor air distribution system to VRF and central chill water system, air source heat pump. So all those things, we don't have to model from the scratch. We can do it from the scratch, but the basic layout is available within the design builder, and we can use that as a starting point to develop our model further. Then ground source heat pump. So I'll show you how to just import those modules and use it within our model. For the ASHRAE 90.1 and LEED, so all of you who must have worked on the energy credit of LEED and ASHRAE 90.1, so you must be aware that we basically have to compare the proposed case with the ASHRAE 90.1 baseline case, and then once the two cases are compared, we have to fill the MEPC calculator, which is the minimum energy performance calculator and we basically submit it to USGBC for approval for the credit. So it's a semi-automated, or you can say it's a sort of almost an automated process within the design builder, that we only have to model the proposed building with all the controls and whatever is there, and then we just have to click on the automation of the baseline generation, and it will take into account all the protocols which are there in the ASHRAE 90.1 for geometry, and it will create a geometry based on the ASHRAE 90.1 Appendix G protocols. Further to that, we can basically put in the HVAC system which basically will come as per ASHRAE 90.1 Appendix G protocols. So it's a guided HVAC generation. So we can define the number of floors and what is the conditioned area, and based on that, it basically guides us as to which system should be modeled. And the basic controls and all the sizing parameters are already within that module, which is there within the design builder. So we don't have to go into controls to that much extent, because as per the ASHRAE requirement, those controls are already inbuilt within the HVAC for the baseline. Then it will automate it for the proposed. It will compare the proposed and baseline case, and then there is a mechanism to import all these outputs within the MEPC calculator. So, and that is basically the most tedious part, because it takes a lot of time to basically import inputs. So if we are doing it manually, then it takes a lot of time, but within the design builder, it's an automated process, and we can import all those inputs within the MEPC calculator and submit it. So so it's basically a very optimized workflow, wherein we can save a lot of time, lot of work hours of our team, and it's a very efficient process. We have been working on this process for so long. Then so design builder has published multiple guides. So there are multiple guides within the design builder for multiple modules. So for Appendix 90.1, Appendix G calculate user guide is there. Then we have MEPC guide, and apart from that, there are multiple guides as well, which are available on the Design Builder website. You can use it and you can refer to it so that you know what inputs are there, what is the definition, and what are the possible outputs that we can generate. So it's not a black box sort of a thing wherein we don't know what is going in and what is going out. We have a fairly good idea of what kind of inputs are going in, and certainly because Design Builder is the front end of the Energy Plus. So the backend engine of the Design Builder is the Energy Plus. So Energy Plus in itself has a very detailed running into thousands of pages. They have their input and output documentation, engineering documentation, which is available for free. So then we can cross refer any input parameter or output parameter from the Energy Plus output database as well. So in that way, it gives a lot of flexibility, and it's sort of an open source thing that we can see what kind of input we are defining and what impact will have on the possible design outcomes or the energy or the load sizing or any kind of output that we are looking at. Yeah, so as we have discussed, we can model the PV systems, but we can even integrate it with the demand side and demand side. So, for example, if if we have a PV array, so we can model the PV array, we can model the inverter efficiency, we can model the module efficiency, we can model the losses, and then we can even integrate this thing with the on the demand side. So we are optimizing the demand side on one hand, and we can optimize the supply side on the other hand as well. So it's a very powerful tool wherein we get to know how much percent of the total demand we can offset through PV, and then those output basically comes into output reports as well. So showing what percent of our electricity we can offset from the proposed solar system. So it basically gives us a fair idea of where our buildings stand in terms of energy demand or the need. If suppose we are doing the net zero feasibility, so that it will give us a very fair idea in the very start of the design regarding the feasibility of all these renewable systems with respect to the demand of the building. For the natural ventilation, so we can model the natural ventilation. So within the Design Builder, we have two modules. One is the scheduled ventilation, and one is the calculated ventilation, natural ventilation. And so within the scheduled ventilation, we can define at which point the Design Builder, the windows will open, and what ACH, air changes per hour, we can predefine those things, or we can use the more detailed or more accurate method of calculated natural ventilation, wherein it will take into account the wind speed, the buoyancy, and the pressure difference outside and inside. And then we can even define controllers for temperature and humidity. So if suppose we want the windows to open at a certain temperature, once the temperature outside is very good, so windows will open. So these kind of controls we can define within the Design Builder, and we can integrate this natural ventilation with the room wall or any other kind of double skin facade as well that we want to model. So all these possibilities are there, and the impact of that can be seen. So on the left you can see we did an analysis on the effect of insulation on the air temperature for the top floor and the second floor, and how it affects basically how the natural ventilation temperatures vary within the building if we change the insulation level. So these kind of analysis, so the possibilities are endless. If you want to analyze, we even within the natural ventilation mode we can do the mixed mode simulation, wherein we can integrate the natural ventilation with the HVAC system. So that is also the possibility that we can look into. Then for the parametric analysis, so that was so the initially right now whatever we have discussed, it was something that we are manually trying to optimize. So like for example here, if I just show you, or maybe we are trying to optimize the impact of insolation on the indoor temperature. But if suppose we have multiple parameters and we want to see which is the most optimum value which we should go for the design, and we can even include the cost into it. So for example, if you see over here, what we are trying to optimize is the energy. So EUI is the object which we are trying to optimize, parameters which are basically the variables. So total building cost, window wall ratio, glazing type, shading type. So these are the 4 parameters which on, and based on the multiple correlations and multiple simulations, design builder will show us which is the most optimum design combination of design, and we can choose multiple design options for the parametric optimization within design builder. So it's a very, so on the vertical axis you can see total building cost, and on this horizontal axis you can see the energy, and sort of it's showing that these parameters are in a way most optimum if you want to optimize the cost and the energy. So that we can do, and it's fairly very simple and very intuitive, and we can perform any kind of simulation, and we can even optimize any kind of variable that we want to do. Then for those who want to go deep into the sensors and actuators, and they want to write their own script for controls, or if suppose there is something which they feel that it's a novel thing, it's not available within the module, so with the Python interface and energy plus EMS interface, we can write our own scripts, and then our system or our operation can be optimized or can be controlled using those particular scripts that we can develop ourselves. So that is also one of the possibility, and it's a very advanced tool which we can go for parametric analysis optimization, or maybe the uncertainty or sensitivity analysis. So this also we can perform. So for life cycle analysis, it's a very hot term which is right now going in. So design builder has an integration with the one-click LCA tool, and whatever information we feed into the design builder, it basically goes into the one-click LCA tool, and and then it automates if the design that we have proposed or the carbon footprint of it is above the baseline, or it's not there. So there are certain manual inputs, but most of the inputs, around 90%, design build the LCA tool takes from the design builder software itself. So it eases out our process of putting the things manually, and the cost, total volume and of the structure, and total volume of the spaces and the materials which are there. We can feed it into design builder once we are modeling, and then once it goes into LCA, it will automate it and show us if where do we stand in terms of carbon footprint. We can even perform the external CFD analysis. So if you want to see what is the impact of outside wind on the pressure of the building, or if you want to see what will be the impact of if you want, we are designing the pedestrian movement, and if you want to optimize the wind movement across, so that we can even do. And for the internal CFD analysis, we can even see how if there are any hotspots within the zone for the HVAC system once we are designing, so that those things we can even perform within the design builder. Then if you see, we can even perform, we can go up to hourly or sub-hourly level, and if you want to understand what is the zone temperature, what is the surface temperature, or what inputs are basically affecting our overall output income, we can do this minute analysis on multiple graphs within the design builder. Or if we want, there is a very good tool which we can export the output to, and then we can do that post processing in that tool as well. So so this is just a brief of what design builder can do in a brief. I'll just switch over to the design builder software update, so to give you an introduction of how the software looks and how we can work on the software.